Okay, question 11 then. So we got functions and an inverse function. So I'm going to start off, we've got the function of x is equal to the cube root of x, g of x is equal to 2x plus 3, and then we're told that h of x is equal to f of g of x. Find h to the minus 1 of x, or the inverse of x. So I'm going to start by working this out. So to do that, I need to put the function of g into the function of x. So I'm in effect substituting, wrong way around, I'm in effect substituting and placing g of x, and I'm substituting that for x. So h of x is going to be equal to the cube root of, instead of x, 2x plus 3. So to find the inverse, how you kind of do this is up to you. I tend to, just for simplicity of explaining it, call the h of x, or the function of x, y, and then in effect what I need to do is I need to rearrange to make x the subject, and then I'll get a function in terms of y, and then the inverse would actually be x would then be the inverse, and then I'd replace, instead of y I'd write x. So I'm going to start by cubing both sides. So if I cube both sides, I would get y cubed is equal to 2x plus 3. I would then minus 3 and then divide by 2. So y to the power 3 minus, y to the power 3 minus 3 is going to be divided by 2 is going to be equal to x. So that's in effect my inverse, but I just need to re-replace. So in effect what that means is that h to the minus 1 of x is going to be equal to, and then I rewrite this with x instead of y. So x cubed minus 3 divided by 2. And here on my answer line, x cubed minus 3 divided by 2. Okay, so in terms of the mark scheme, then we pick up a method mark for h of x, and they do agree with me there, so M1 there. We then get the second method mark for the first step of method to find h to the minus 1 of x, which is cubing, and they've actually suggested a slightly different method. They've called this x and they've called this y, but either way you pick up that for the first step, and then A1 for the final mark. Okay, question 12. The number of insects in a population at the start of the year is n is Pn. The number of insects in the population at the start of year n plus 1 is Pn plus 1, where Pn plus 1 is equal to k times Pn. Given that k has a constant value of 1.13, find out how many years it takes for the number of insects in the population to double. You must show how you get your answer. So in effect, each time we're timesing this by we're timesing the previous value by 1.1, so that will be the number of years in effect. So realistically what we want to find out is the point where 1.13 to the power n is greater than 2. So we could, if anyone's doing this paper who is an A-level student, we could look at using logarithms to help us out here. Alternatively, I'm going to suggest probably the most straightforward way is to say that I'm going to put 1.13 as my answer. And then I'm going to times that by 1.13. So that would be, so let me just say, when n is equal to 1, we get a value. When n is equal to 2, when n is equal to 3, we would get 1.13. When n is 2, we would get 1.27. 3 would be 1.44. when n is equal to 4, when n is equal to 5, when n is equal to 6. Let's go that far. When n is equal to 4, then we would get 1.63 dot dot dot. When n is equal to 4, we get 5, 1.842 dot dot dot. And that's the first value where n is greater than 2. So how many years does it take for the population to double? That would be 6 years. Okay, and part B, the value of k actually increases year on year from a value of 1.13 in year 1. How does this affect your answer? The number of years will decrease. I think that's all we need, really. Number of years would decrease. Okay, right, if we look at the mark scheme then, M1 is given for a method to calculate 1.13 to the power n where n is greater than 1. So I could pick that up just for that line there alone. And then it is an A1 for 6. And then for part B, for example, the number of years will decrease. Number of years would decrease. So that's a C1 mark. Okay, question 13 then. Right, solid cone is joined to a solid hemisphere to make the solid T shown below. The diameter of the base of the cone is 7 centimeters. The diameter of the hemisphere is 7 centimeters. The total volume of T is 120 pi centimeter cube. The total height of T is y centimeters. Calculate the value of y, giving your answer correct to 3 significant figures. Okay, so for this, we're going to have to start by so I'm going to start by calculating the volume of the hemisphere. So I'm going to call that VH. So that is going to be half of this. So it would be 4 over 6 times by pi times by 3.5, because the radius would be 3.5 cubed. So I'm going to leave my answer in terms of pi. So 4/3 is the same as 4/6 is the same as 2/3. So I'm going to go 2/3 times by 3.5 cubed. So I'm going to go for, in terms of pi, 343 over 12 pi. Next thing I need to do is to work out the height. Although I'm not going to be able to work out the volume of the cone quite. So what I'm going to say is, just trying to get my head around it, what I will actually say, I'll come back to this in a second. So the volume of the cone, so I'm going to call that VC, is going to be equal to 1/3 of pi times by 7 square, no, not 7, 1/3 of 3.5 squared times by the height, which I'm going to call y minus 3.5. Right, so just trying in my head to work out at what point I'm going to move things around. So I'm going to stick with this. So the volume of C is going to be equal to, let's do that, 1/3 times by 3.5 squared is going to give me 4 pi over 147 times by y minus 3.5. Now these two things need to add up to 120 pi. I'm just thinking about taking a shortcut. No, we'll stick with that. Okay, so the total volume, so 120 pi has to be equal to these two things added together. So we're looking at 343 over 12 pi plus 4 pi over 147 times by y minus 3.5. Right, I can cancel the pi's out straight away. And then I'm going to do so I'm going to do 120 minus this fraction here, so 343 over 12. So that gives me that value. I'm going to times that by 147 to get rid of this fraction here, and then divide by 4. So if I times that by 147, that gives us that, and then if I divide that by 4, that gives me that value there. I'm going to have to double check this because that's not very nice at the moment, and that's going to be equal to y minus 3.5. So if I then add on 3.5 to that, so plus 3.5, that gives me that as a value, which seems ridiculously big. So let me just check some of my steps here. What I'm going to do is I'm going to tidy this up and then rework it. So I said over here I could have left it a specific way, and I'm going to do that now just to save having such complicated fractions. 1.5, 3.5, maybe I typed that in wrong, squared over 3. So let's try that calculation again. Right, so the total volume, 120 pi, is going to be equal to 2/3 times by pi times by 3.5 squared plus 3.5, that's cubed, sorry, 3.5 squared over 3 times by pi times by y minus 3.5. Right, so still going to cancel through by pi. If I times all parts by 3 now, that will give me 360 is going to be equal to 2 times by 3.5 squared plus cubed, sorry, plus 3.5 squared times by y minus 3.5. Okay, so if I rearrange then, I should have 360 minus 2 times by 3.5 squared divided by 3.5. Divided by 3.5 squared, then I should be plusing 3.5 from that. See whether that gives us a better answer. So 360 minus 2 times by 3.5 cubed, again I've not done that very well, cubed, divided by 3.5 squared, and then from that I need to minus 3.5. That looks much better, but not right still. Right, let's just double check my steps. Volume of the first one is 2/3 pi r cubed. Volume of the second one, 1/3 pi times 3.5 times y minus 3.5. Right, that looks okay. So I'm thinking that might be to do with my rearranging. Right, so if I times through by 3, that would give me 360, 120, 360 is equal to 2 times by 3.5 cubed plus 3.5 squared times by the height. So that looks right. Check my steps then. Minus from both sides, divide by that, and then add that. So that looks right. So I'm struggling to spot what mistake I've made. So 360 minus 2 times by 3.5 cubed divided by 3.5 squared minus 3.5. Plus 3.5, there we go. There we go. So that is going to give me y is equal to, so y is going to be equal to 25.8877 ... which is going to be 25.9 to 3 significant figures. Right, marking for that then. So P1 for the process to calculate the volume of the hemisphere, which was that step there really. P1 for method to find the process of the equation that links the height of the volume to the shape, so I'll go P1 there. P1 for the process to find the equation equal to y, so where can I award that? We'll award that there. And then A1 for 25.9. Oh, and that's only part A. Part B. The diameter of the base of the cone and the diameter of the hemisphere are both increased. So let's look at the diagram again. The diameter of the base of the hemisphere are both increased by the same amount. Assuming that the total volume does not change, explain how this would affect your answer. The height of the shape would need to decrease. So the height of shape would decrease. Okay, and I'm just assuming, yeah, there we go, and that's just a C1, so C1 for that. Right. And question 14. So we've got a cuboid. Work out the size of FAH. So FAH. So that one to that one. Okay, so AD is 9. So we've got 9 there, 9 there, 9 there, and 9 there. FD, F to D. Well, okay, interesting. F to D, is that definitely right? F to D. Okay, that length there is 13. And angle GHF. GHF. Okay, right. So, which is G, H, F. Okay, right. So I'm going to do it this way. So if I know that length is 9, I'm just trying to work out which steps to do. I could work out that. Could work out that length there. Let me just undo that. That's not what I quite wanted to do. I think I've just erased all of my writing. Let's just check. That didn't quite work as I hoped. There we go. That's actually what I wanted. Right, so I'm going to do this in these stages. I'm going to work out that length there, which I'm going to call X for now. Once I've got the length of that side, okay. I feel like I've got to do 3 stages for this, which doesn't seem quite right. I'm going to start by working out that length there. So that length there is, I'm actually going to call X for my first step. So X squared is going to be equal to 13 squared minus 9 squared, which is going to be equal to, so the square root, so X is going to be equal to 13 squared minus 9 squared. And I'm going to try and leave it in third form if it's nice, minus 9 squared. So I'm going to call that 2 root 22. Right, now so that side over that side is going to be equal to okay, so in effect now for my next step then, what I'm going to work out is, I know that we've got a 49 degree angle there, and I know that the and I know that that length there is 9, and I'm going to want this length here, so I'm going to call this Y for now, and that gives me the 2 lengths that I need to work with. That makes sense. So Y is going to be equal to, so this is the hypotenuse and the adjacent, so it's cos and so I'm saying that Y is going to be equal to 9 over cos 49. So Y is going to be equal to 9 divided by cos 49. So that's going to be 13.718 ... So finally then, if I actually want to work out, and again I'm going to go for a sketch of this, I want this angle here, and I know that that's X and that's Y. So tan of the angle, or the angle, is going to be equal to tan to the minus 1 of the opposite, which is x over, no, calculate the angle FAH. That's the actual angle that I'm trying to work out. That's the angle I'm actually trying to work out. So y is the opposite, so y over x. So on my calculator, I'm going to go shift tan, fraction button, and for my last answer I typed in over 2 root 22, and close my brackets up. Whoops. Close my brackets up, and that gives me the value of 55.6349. So to the nearest degree, that's going to be 56 degrees. Right, mark scheme for that then. So I'm looking at, where are we? So it is a processing mark to find the length FH. There we go. So that's P1 there. Second processing mark scheme actually shows it beforehand, right? So they've gone for root 88. I kept it in third form. Processing mark for tan, and then an A1 mark. So that's the 4 marks.